Just a bit of context on why we chose this topic today. So we found that it goes with the theme of the Imbizo, which is sustaining the future of engineering. And we also found that not a lot of people are aware of what exactly the fourth industrial revolution is, and if it really has any relevance to the civil engineering sector. Okay, a lot of what we will be discussing overlaps a bit with Keith's presentation. So yeah, okay. Just an overview of what we'll go over. So a quick introduction to Industry 4.0, because I think Keith has already mentioned that. Then we'll look at the technological pillars that make up Industry 4.0. So Industry 4.0 and the fourth industrial revolution are synonymous with each other. Then we'll look at its how it can be implemented in the civil engineering sector.
I'm just going to look at the technological pillars that will bring about the next industrial revolution. So these technologies have been identified as autonomous robots, simulation, systems integration, the Internet of Things, cybersecurity, cloud computing, additive manufacturing, augmented reality, and big data. So I'm just going to give a brief explanation of what these technologies are. So big data is a large complex set of and the importance or the benefit of this is that we can convert this data into knowledge. So we can identify trends and patterns, and this can allow us to optimize our designs and also make real-time decisions. With augmented reality, this is augmented imagery that's placed in front of the real world. It's most popular amongst the gaming industry, but we can use this technology to better visualize our designs. Simulation is imitation of a process, or environment, or a situation, and we have been using 3D simulation in our industry, but companies are now using virtual reality to better visualize designs, and this can also help optimize designs, and we can also use simulation technology to train employees about working in unsafe environments. And we can also identify risks because we can visualize designs better. I think Keith went over the Internet of Things, which is basically connecting the internet to everyday items. So imagine that your car has access to your calendar, so it can know that you have a meeting on the day, so it'll plan the best route for you to get to your meeting, and if you're running late, it will notify the other person that you're running late. Or something like office equipment can detect whether it's running low on supplies, and it will automatically order more material before it runs out of material. With cloud computing, I think we all use cloud computing. If you're sending emails or sharing information over the internet, that is cloud computing. But the benefits of cloud computing is it reduces IT costs because you don't have to spend money on the hardware and the equipment to run a server. Another benefit is that it'll be easier to back up and recover data because the information is mirrored on several sites on the cloud provider's network. Cybersecurity, so with the Internet of Things and cloud computing, we're sharing a lot of information on the internet. So we need to protect our data better. So things like intellectual property, information about your clients and designs will need to be protected because if they are hacked, then you could face legal charges, loss of assets, and loss of your reputation. Systems integration just is basically making sure that your organization works as a coordinated whole across the various platforms that you use in your organization. Then advanced robotics, I think we're all concerned that our jobs might be replaced by robots. So with things like drones, autonomous robots, self-driving cars, construction vehicles, they will have an impact on the way we live as well as on the way we work. And there's a field called cobotics, which is using robots to assist humans with tasks. But with the ongoing developments in artificial intelligence, we need to make sure that our skills aren't replaced by robots. Additive manufacturing is basically 3D printing, and this type of technology is being used around the world. It can be used to customize components for your structures, and there's been a 3D stainless steel bridge that's been built in Amsterdam. It's being used to deliver housing in China, and Dubai has been using 3D printers to build the office building and a museum. So this technology is being used.
The civil engineering sector has been slow to adopt new technologies, and there hasn't been any real major shifts in technology, but this will change with Industry 4.0. So with the fourth industrial revolution, it will change the way we work on our projects, what our projects need to accommodate, and also how we do business in the sector. Okay. If you had to do a Google search on Industry 4.0 and the civil engineering sector, one of the first things that would come up is BIM, or Building Information Modeling. It's not as commonly used by engineers as other built environment professionals like architects, but it does have the potential to become a big part of our industry. So I'm just going to look at BIM and other aspects of Industry 4.0 that can be integrated into each part of our project cycle. Okay, so on the planning and design phase, we all know the traditional approach. So we have prelim design, then we have detailed design, then it goes into construction, and then there's operation and maintenance. So these processes are fairly independent, and one can only happen once the other has completed, which works well. I mean, that's the process most of us use currently, until there's a design change. And at that point, you need to go back and change your drawings, and it's a bit time consuming. Okay, and obviously we have time and budget constraints. So often what happens is the solutions that we have for projects, they meet the code and they fit for purpose, but they're not always the most optimal solution. Okay, and this is where BIM is different. So with BIM, you'll have a dynamic model of the project, and any changes that you make are dynamic. So you don't need to, you have more time to optimize your models. Also, all of the information is stored on one model. So this helps if you have a project with lots of interfaces, because you can quickly identify any design clashes earlier on in the project. Also looking at other technologies, so we have 3D laser scanning. So with that, basically, we can use laser scanners to get a virtual model of the current infrastructure to better understand what's currently happening. There's also aerial mapping technology, which we've spoken quite a bit about, so like the use of drones to get surveys in areas that are dangerous or difficult to reach. Okay, big data driven design. So Prinaven touched on that a bit, but it's basically the use of data from different sources to make sure that our projects are more suited to our end users. So for example, if we're doing a traffic analysis at an intersection, then we can get information from mobile surveys, traffic camera footage and things like that, so that our designs are more accurate. Okay, then simulation and rapid prototyping. So I think most people are aware of this 3D printing. Our dams and hydro department actually has a 3D printer, and they've used it on some of their dam designs. It's also been used in Barcelona at the Gaudi's famous Sagrada Familia Church, which, so basically they're using 3D printing because the design is so complex, so it allows them to visualize the design better. Okay, then when it comes to the construction aspect of the project cycle, with BIM, it helps to coordinate all stakeholders that are involved in the project, because you have one model, so you don't have to worry about is the information missing or things like that. It also helps with constructability, because often you find contractors that might find certain drawings that are ambiguous or they don't fully understand them. So with this, they have a virtual model of the project, so they can better understand what is expected. Then on the operation point, on the operation side, so once you complete a project, you would have a virtual model of this project, and that will include any data that relating to the project, including test and inspection data. So this is especially helpful for future expansions, because often if we have an upgrade, then we need to hunt for as-built data and things like this, whereas now you have a model that has all that information at one point. It also helps on the maintenance side. I think someone else also touched on this. We can use 3D laser scanners, so we continuously monitoring the infrastructure, and it cuts down the amount of manual inspections needed.
Just to look at some of the trends that are occurring in the world at the moment, we know that population growth is increasing and that there's rapid urbanization that's occurring. So cities have to think about delivering infrastructure at a higher rate, as well as the environmental impacts of providing infrastructure for the citizens. Also, cities have to think about mobility and transport and the energy requirements of these citizens. And with the Internet of Things, this will allow cities to become smart cities where information and communicational technology can be used to optimize the services for the citizens. So with prefabrication and modular construction, it's very popular amongst the commercial because it's eco-friendly, because most of the construction is done off-site and is just installed on-site. It will allow for better or faster delivery of services, and it is cost-effective because there's very little disturbance on-site. It's not a very new technology, but with things like 3D printing and customizing components, it will have an impact on producing infrastructure faster. And there's a vast amount of research and development being done in material science. So there's things like pollutant digesters, which are material that can remove pollutants from the air. There's a cement additive called photoment which can do this. Then there's nanotechnology, which is manipulating the characteristics of a material at a nanoscale in order to improve them. And it has been used on conventional building material like concrete and steel, but there is developments in a technology called smart dust technology, which are very tiny sensors that can monitor environments in terms of temperature, chemical composition, which can prove useful for engineers. Then there's high performance material. We all are sort of familiar with things like geosynthetics, polymerics, and fiber reinforced concrete, but there's always developments in these fields. And there's bio-based materials, which are materials made out of eco-friendly, sustainable material. And then there's programmable material, which could lead to the design of structures that can dynamically respond to the environments that they're in. So there's a lot of material that we can use in our projects, but we need to keep up to date with these advances so that we can implement them in our projects. Then in order for cities to accommodate the movement of people within the city, there's a trend that cities are using to deal with the problem and they're using mobility as a service, or providing mobility as a service, which is basically creating a digital platform which allows you to plan and book your trips from end to end on a digital platform over public and private transport networks. So countries like Finland, Germany, and Austria have these systems in place, and recently, earlier this year, Gounden Move was released, and this shows that we are keeping up with trends in the global market. And then things like autonomous or connected vehicles will allow us to optimize our transportation networks, because these vehicles are constantly interacting with each other as well as monitoring their environments around them. Then the technology that Industry 4.0 bring will probably most likely accelerate the implementation of sustainable energy projects. So things like solar power, wind power, tidal power projects, other sources of sustainable energy will become more popular because the technology that will be used to implement these projects will become more accessible and more cheaper, and countries are moving towards the sustainable energy, sustainable development goals, and reducing the reliance on fossil fuels. So when we talk about Industry 4.0, there's a lot of buzzwords around, and we're not sure how they will impact the way we work. So we looked at some of the things that are in the future that could impact the way we work. So things like data and connectivity, blockchain and quantum computing do have a potential to impact on the way we work in the future. So I don't think anybody's going to complain about having faster internet or internet with wider coverage. So things like 5G connectivity, Wi-Fi, Bluetooth 5.0 are going to increase the way we share information. But because we're sharing more information and with wider coverage and things like that, we need to consider cybersecurity more because our information can be hacked. Wi-Fi is basically using light to transfer data. Blockchain, I think Keith explained the whole concept, but so the one thing is that once a block is created, it cannot be altered and it is permanent. So the implication for using blockchain technology in the construction industry or civil engineering industry is that when we're working on projects during design and construction, there's a lot of information that's being shared between the client, the project team, and the contractor. So it can provide a legal basis of who did what when, especially like recording things of quantities of works done on site. So it can provide a digitization of the contract, so there sort of will be smart contracts that can be used to implement projects. Then with quantum computing, this is basically going to accelerate the way we can compute and model our designs. It's not a technology that has been matured yet, so quantum computing relies on qubits, which is different from traditional computers where it works on ones and zeros. A qubit can be a 1 and a 0 at the same time. So it can allow us to model multiple constraints and model our environments more realistically, so we can create more what-if scenarios and optimize our designs better.
Okay, looking at the impact of Industry 4.0. So relating it to the triple bottom line, we've looked at how the fourth industrial revolution will help companies make a higher profit, and because we'll be more efficient, we can optimize our designs, we're going to save on cost. It also helps us to remain competitive. We've seen how it affects the planet, as there's a strong focus on sustainable designs and green buildings. But we haven't considered the last aspect, which is the social aspect. Okay. For many people, when you think of Industry 4.0, you think of a loss of jobs and structural unemployment. We also know that developed countries are more open to adapt to technologies from Industry 4.0 because their sectors aren't as labor intensive as ours. So for them, they are looking at Industry 4.0 as a way of achieving a better work-life balance, whereas for us, it could lead to unemployment. We also know that the construction industry in particular is seen as a silver bullet for job creation, and we have many programs like the EPWP, and even the CIDB has best practice principles that stress the importance of labor-intensive construction purely for absorbing the poor and providing employment. Okay. However, if we don't adapt to some of the technologies of Industry 4.0, there could be consequences. And a good example of this is the cell phone company Nokia. So I'm sure we all know that Nokia was the leading cell phone brand in the late 1990s to 2000. And I'm sure all of us have fond memories of the 3310 battery. But what happened is the internet came out, and other cell phone companies like Samsung, they noticed that data was the future of cell phones, whereas Nokia thought that voice was the future, and they didn't really want to change their brand too much because they were scared of losing their current client base. And in turn, that's what led to their downfall. I mean, how many of us still own Nokia cell phones to this day? Very few. Okay, but it's so in the same way, if we don't adopt some of these principles, we could become less competitive internationally, and this could lead to job losses anyway. But there's also the concept of African solutions for African problems. And that basically means that we need to adopt principles of Industry 4.0 that are relevant to our situation. So if, for example, we have a project in a rural community where there's lots of unemployment and it's also costly to transport equipment to the site, it doesn't make sense to have a fully mechanized site. In that case, it's better to use local resources. Okay. Also, the impact of Industry 4.0 has a lot to do with government policies and how they are set out. So government plays an integral role in this. What I think is that government has to look at which sectors will are most likely to be affected by Industry 4.0, and look at how we can minimize job losses in these sectors, and look at redeploying people to different areas that where jobs could open up with Industry 4.0, and also look at reskilling people in the industry.